Up next is Milko Kostrukov with the Minimize the Framework and Allow Yourself Some DDD. So let's hear it for Milko.
Hi, hi, all. It's very nice to be here in person and for the first time as a speaker. And it's nice to be back in Serbia and to be back with friends and at a really nice place. And I organized the conference in 2019 in Bulgaria, and I know what it is for the organizers. I was very lucky that because of burnout, I didn't start the organization of the next event right away. So we did miss the whole mess with the COVID. And I can only imagine what it is for the organizers of PHP Serbia to be involved in all the mess. So kudos, guys, like, great job and thanks. It's really nice. So my name is Milko. I'm a PHP developer, although I'm trying to be more than PHP developer, but yeah, I explained this to HR. Like, they're not really falling into it, or to managers. Anyways, I am a PHP developer. I've been a PHP developer for quite a while. And I've done like quite a lot of stuff throughout the years, different stuff. Right now I'm a contractor. As I said, I organized the conference, wanted to organize more events, but yeah, COVID, we all know about this. And I'm trying to figure out what to do next in my life. So I've done quite a lot of different projects throughout the years. I'm not gonna tell them all because it's just not interesting. So, to the talk. What are we going to talk about? I'm not going to give you or try to give you a detailed explanation of what domain-driven design is about. I'm just gonna sketch out some more important things that I think that's like the philosophy, what the philosophy is and why I like it. And then we're going to try and look how our frameworks take on the what an web MVC take on software development is like, and whether we can work with this, with domain-driven design, how to use them, and what we're doing wrong maybe how we can improve, and see if we can figure out a better way to do stuff. So, as I said, a quick look at the most important things in DDD, in my opinion. The problem that occurs when we try to practice it, well, at least the problems that we faced, when we tried to practice it for the first time, and what to do, and of course, profit. So just a quick introduction, domain-driven design. It was coined by Eric Evans. The term was coined by Eric Evans in his book, Domain-Driven Design, Tackling Complexity in the Heart of Software. Note that we're going to be talking about, well, we're not going to be talking about complex software because I've tried to come up with an example, so it's not very complex. But the whole idea is that it's reasonable to apply domain-driven design when we're talking about reasonably complex domains. If we're making a CRUD application, well, maybe it's an overkill. So the important parts that I think are, well, important philosophy-wise in domain-driven design. So first, obviously, we focus on the domain of the problem. We don't focus on infrastructure. We don't focus on databases. We don't focus on languages. We focus on the domain of the problem. The domain of the problem, you know, I had a problem understanding what a domain is. So it's basically the problem. This is what you're trying to solve. This is the field that the people you're going to give the software to use are working in. Second, collaboration with the domain experts. And the domain experts, like a fancy term for the people who are going to use your software. These are the people who are actually doing the work, not the programming, the actual work that your software is going to help. Those are the domain experts. We'll give an example of who a domain expert is. Usage of ubiquitous language. This is not a fancy term, ubiquitous language. It's basically tells us, like, there is a language, a jargon, which appears in the day-to-day work life of people in all sorts of fields. So it's one domain language if you're an accountant. You'll be dealing with the invoices, for example, or credit notes, or I don't know what those people are dealing with. It's really not my thing. So this would be your domain language. If you're a medical doctor, you'll be dealing with patients, you'll be dealing with diseases, you'll be dealing with vaccinations. So this would be your domain language. And last but not least, recognition of bounded context. Bounded context, another fancy term about a subdomain of the domain, basically. Because, you know, if you have a big domain, a big field, like, as we said, medical doctor, or maybe you have you have to deal with administration, you know, filling out documents, and then you have another domain, subdomain or bounded context, which you would be giving examinations, and so on and so forth. So you'll be doing different stuff, which are all being a medical doctor. So let's look at an example. So music idol, that was something we did in the very beginning of my career. I worked for a company that was owned by a TV production company, and I learned that there is going to be Music Idol. It's a music contestant show in Bulgaria, and I was really hyped because I heard Antonio mention that he doesn't know what a rockstar developer is. I'm a rockstar developer because I'm actually in a rock band, although the stardom didn't really happen. But I'm a rockstar developer. So I wanted to go to the competition. Didn't happen. Why? Well, because on the next day after I learned, I went to work, and there I learned that we are actually going to be doing this. That our owning company is going to be producing this. And we're going to be building a software to help and aid the production company be more productive in managing this whole new thing that they're going to be doing, like this huge TV competition. So that was the domain. Help all the teams involved in the production to do their job quicker, easier, with better quality. No idea what this actually meant. But yeah, we had to help them. So we have no idea what we're supposed to do because we have no idea what needs to happen, right? We are developers. We don't go do TV shows. So what you do in this situation is you go to talk to the domain experts. So the domain experts, they're the casting team, for example. These are the people who deal with the contestants and say, like, okay, this guy's good, this guy's not good, this is a retard. The assistant directors, they basically deal with describing. It used to be tapes. Now it's all digital, but it used to be tapes. So they would be describing on which tape at which time code what happens. They would then do montages of various things that happen, make funny videos, for example. You know, a contestant is singing and then a dog comes and pees it, stuff like this. The wardrobe and makeup people, well, it's pretty obvious what they do, you know. And the producers, the producers are basically the managers of the whole thing. So they would be managing the whole thing, and they would be paying for stuff, and they would want to know the expenses, and they would want to know where we are with the schedule. So different domain experts dealing with different bounded contexts. And yeah, to figure out what you need to do, you just go around and talk to them. It's very important. This is how you learn what your problem is. And again, Antonio talked about this. You need to know what your problem you're solving in order to solve the problem, right? So you go around, you ask people, you talk to them, feel their pain, feel their worries, and then come up with a solution. And the ubiquitous language. Well, for us, it was like something like contestant, list of contestants, a location. Location in particular meant where somebody is supposed to come for a casting, where the castings were held. The rooms, this was a particular room of the location. A tape, I told you what the tape is. A time code, it's a time code on the tape. Rehearsal, you know, like just notice that there is no database, there's no server, there's no MVC involved. And the bounded context, well, kind of like we went through the domain experts, so kind of know, like there's contestant sign-up, there's contestant communication, there's casting management, There's videotapes management. There is time tracking. User roles. Oh, we all have user roles, but yeah, you have to put this. So stuff like this. It's really not that hard. The whole point is, like, put yourself in the shoes of those people. And when you develop the software that you're developing, try to use those words in it. Try to name your stuff along this way. Try to structure it in kind of like something similar so that when you look at it, it tells you, okay, this is a casting management system. So, I have to admit that was quite a long ago, but it's a good example. So, how would solving this problem look if we were doing it today? So, we start with a quick setup. We install our framework, and we get a file structure. Now, you recognize this file structure, like the framework? Does anybody know which framework this is? Yeah, exactly. It's Laravel. Yeah. Yeah. So there are at least a couple of people who know which this framework is. Only looking at it, the directory structure, and let's see what we have. Like we have console stuff, we have exceptions, we have HTTP. In HTTP, we have controllers and middleware, kernel. We have models, we have providers. God knows what provider is. Well, using Laravel, you know, but I'm a provider as well. I provide for my family, right? So we have Bootstrap, config, database, obviously, because we cannot build an application without a database. How could that happen? Public. Urination comes into mind, but it's not that. Resources, routes, so on and so forth. Obviously, we don't have anything about, casting management, or TV productions, or music idols. Nothing of the sort. Because obviously, Laravel cannot know what we're doing, so they provide for us what they know. They know about controllers. So there's no focus on the domain in this. Okay. There is no ubiquitous language. Okay. It's unclear bounded contexts. Well, actually, the bounded contexts are clear if we're talking about infrastructure. That's fine. That's easily separatable. We got HTTP, we got console, we got database. So those are different contexts. Only it's infrastructure. It's not domain. So this can actually be a blog. It can be anything. What you know is that it's a Laravel thing. It's a Laravel framework. It can be a blog. It can really be anything looking at this. So, as we said, it's kind of normal because Laravel and any other framework for this sort. As a matter of fact, I chose Laravel simply because it's very popular, and I did a lot of development for the last year with Laravel, so it's kind of like the freshest thing. But pretty much all the frameworks, pretty much Symfony is trying to get out of this. Pretty much all the frameworks that I've ever seen, they're similar. So this applies for pretty much everything that I've seen. So they don't know about our domain, and that's absolutely normal. Like, how could they? What they know is infrastructure. And this is what they give us. They give us web MVC, easy work with input-output, easy routing, DI containers, database access layers, yada, yada, yada. And this is okay. This is good. Because we're going to use a lot of this stuff. I mean, we cannot live without it, obviously. And these are the parts from an application that are actually repeatable, and we can actually easily abstract away before we even start dealing with the application, because we already know that it's going to be there. So that's fine. That's fine. Problem is, it's all infrastructure, and we're lost in the domain. We've lost the domain. So, yeah, one more thing is that because this infrastructure, it kind of tends to leak into our applications. And we just start with this because, it's very familiar, and we like familiar stuff. We like it to be easy, so it seems easy, but it kind of crawls, it creeps into our application until it's all about the infrastructure. And yeah, that's what happens usually. So the point of this talk is to think about how can we avoid that. It's not about how to get rid of the infrastructure or the framework. It's about how to avoid the leaking, creeping properties they have. So, screaming architecture is it's a term coined by Uncle Bob, who is, for some reason, kind of controversial, but whatever. So the idea is that once you open an application, like you look at its structure, you look at how it's built, you already have an idea what it's actually doing, like from pretty much the first glance. So let's check out a kind of a domain-oriented structure, directory structure. I mean, it's not perfect, but just to give an example, like let's run away from the controllers. Oh, let's do a domain subfolder, and this is where we're going to be dealing with domain stuff that we have. And we can have for the different bounded contexts, different directories probably, and we can name our files after what they're actually doing in their domains. For example, add in the contestant, we can add a node, so we know they're nodes for the contestant, and these nodes are for contestants in particular. Allow to next round, so we know that they're rounds, and we can allow somebody to go there, a contestant. They can sign up. And for the tapes, we got like adding tapes, adding time codes. We know that there is this stuff, tape, time code, wardrobe. So we kind of get an idea. This is not a perfect directory structure. I mean, it's just the point is to illustrate that we don't need the controllers. You get an idea. This is not perfect. I mean, depending on what you're doing, it's going to be different. Depending on how you see the world, it's going to be different. Depending on the problem that you're solving, it's going to be different. Just maybe still better than controllers and just models. So let's look at a use case. So this is basically something that our system needs to be able to do. So these are the rules. A contestant is allowed by a jury member to advance to the next level in the competition. Before the contestant actually advances, they need to sign the contract, because if they're allowed to go forward, they need to go on TV, they need to agree to do stuff, they need to take a responsibility to be on time, and yada, 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 stuff like this, so they need a contract. We need to save the contract in the system, because, you know, obviously. And what have I come up with? After signing the contract, a member of the casting team scans the contract, and makes it. The member scans the contract, uploads it, and then the contestant is good to go for the next round. All right. So how would this probably look like with traditional code? We go to the contestants controller. By the way, you have to give it to them. It's contestants controller. I mean, the controller creeped in there, but it's still contestants. So a bit of code. So this would be the controller method. It would be one of many controller methods, usually. We would call it advance to round if we are good at naming stuff. And we're passing in a request because, well, obviously the request is going to advance to the next round. So anyway, advance to round. First thing we do is we check whether whether the user is authorized to advance the contestant. Laravel has this gate stuff here. I really don't see any value in them. Maybe someone can explain them at some point, but okay. I used it just for the sake of it. Then we validate some data, like do we have a contestant ID, which is required data, which round, like to casting or to competition. We check whether we have uploaded a signed contract, so we validate the data, that's fine, it's usual stuff. Then we find the record for the contestant here. We find or fail based on the validated parameters. We get the contestant. And if the contestant is not approved by the jury, or if jury approvals do not exist, then we throw a runtime exception in which we set a message not approved for advancement, because our users need to know what's going on. And then we set a round. We set the advanced by user, which is the ID of the currently logged in user. Then we save. Then the contestant, I mean. Then we store the uploaded contract in whatever our storage is. And then we return a response that redirects to the root of the contestant profile. Oh, good. Is that clear? I mean, so, problem. let's see. There's a lot of stuff going on here, and there's quite a lot of domain logic. So let's look at the domain logic. So the blue rectangle is around where we have domain logic. Next, in red rectangles, we'll see where we have infrastructure code. So first, in the definition of the class, it stands a controller. A controller is part of our infrastructure because controllers, they deal with HTTP requests, right? And HTTP, it's something that's run on the web. Web is infrastructure because it can be a console, right? Or WebSocket. Then we have the request, which is also infrastructure because it's part of the web. And input-output, we got more requests and validation of data here. We got presentation logic, because translating the not approved for advancement is actually presentation logic, because our domain doesn't really need to know how many languages are supported or we have. This is presentation. Then we have a mixture of, this is actually authentication. Authentication is also somewhat of a infrastructure logic. We'll explain why a bit later. And then obviously, we're dealing again with infrastructure because we know that it's a file and that it gets stored in the contestant docs, which is a path somewhere. Now, we can argue that with Laravel, you can create different storages and you can abstract away the storages, which is true. So maybe this is not that bad, but of course, again, you have the request. And it's a file sent through the request. What else do we got? What am I missing? Oh yeah, and of course, finally, the final infrastructure code, we return a response which knows which route to redirect to, again, infrastructure. And now a bit more, which is kind of like, it's kind of okay-ish, but not really. In the yellow fields, those are parts of the code which are domainish, but makes me at least not very happy with it because it kind of gets us married to the framework. So, for example, the authorization, whether somebody is allowed to do something or not, is part of your domain, because it's the domain, like the business logic. Knows why and how and who is allowed to do stuff. So whether somebody is authorized to do something, that's a matter of our domain rules. So it's domain, but it's somehow married to the framework, so I don't really love it, but okay, I guess. Then we have this, again, marriage to the framework. I mean, it's kind of part of our domain, but it's this Laravel thing where you have this like mixture of database and domain stuff, and it's like, and yeah, the contestant, then we save it. It's like this, like all of the active record pattern libraries, but it's kind of okay, but okay. Any more of those? Contestant safe? No, I think not. Okay, so let's recap the issues. We've got domain logic, which is coupled with delivery logic. This makes things very hard to reuse, because this is all designed to work on a web server. Maybe at some point, or not at some point, but maybe by definition, we need this to work on a web server, and also we need to have a command, console command to do this, all of this. But like, how are we going to do it with a console command? We don't have a request, right? So, and we don't have a logged in person, because like it's an HTTP thing. The way you log in into a console is like different. So we're bounded here to this controller. We're bounded to the web. It's hard to test. God, it's hard to test. I mean, yeah, I have to admit, Laravel in particular gives you tools to test all this. our app grew to the more to the moment that we had like more than 3.5 minutes of running tests because they all had to boot up the whole Laravel stack. They had to deal with the database because it's Laravel's active record. You cannot mock a database. You cannot abstract away the database. The Laravel's models are tied to the database. You need to have a running database. So it's hard to test, really. When we have a lot of actions in one class, and I'm referring to this big controller classes that have different actions that are bounded to different routes, but are existing in one controller class, what happens is, well, the bigger the controller gets, the more dependencies it needs to get injected into. Why? Well, because we need something to be injected in the controller to help us retrieve something in one particular method, and then we need something else for another particular method, and then maybe we need something that's used by 2 methods, but not by the third one. So, you know, the dependencies of this controller kind of tend to grow a lot. And the file itself also tends to kind of really grow and become really unmaintainable. So, like, really? Who needs that? And as we mentioned with the yellow squares, we're now married to our framework, which is not necessarily that bad, but you know, frameworks, they tend to get old, and new versions tend to happen. And when this happens, you're scared to upgrade because it will fuck up all of your application and everything. So you stay at the older version for as long as you can. And then it gets unmaintained, and now it's too late, and now you got legacy code. And this is because it's hard to upgrade. And it's hard to upgrade because, you know, everything is a big ball of mud. And we're married to this big ball of mud. We have a ball and chain. Okay. So, let's look at the so-called application service. The application service is basically, it's an entry point to your application. It's basically the logic of something that you're, of a tiny thing, well, not necessarily tiny, but one thing that your application can do. So, as we said, it's an entry point. It holds the logic for your business case. So for, in our case, letting a competitor to the next stage of the competition. It may return the results of something that it did or may not, depending on what kind of pattern you're using. But it's important that it does not know anything about the environment it runs on. So like you can run it on whatever. You can run it on a web server, or you can run it in the console, or maybe somehow hook it to a WebSocket server and have it do stuff like this. Because it's okay, because it doesn't know about the environment, and because it doesn't know, it doesn't care. So that's why it's reusable in different environments. So that's kind of nice, you know. It's really, really, really cool. So let's see. We can refactor our controller to an application service that would look something like this. And now first, notice that the whole the method that we had is now turned into one single class. I like to have those classes invocable, although they don't need to be. They can they basically just implement the so-called command pattern. And the command pattern, if we are not doing object-oriented programming, translates into a function. So because it translates into a function, I like them invocable, but that's really not that necessary. And in this function, we pass in advanced round params. I've seen other ways to name those stuff. I like this. It's kind of intuitive for me. And this is an object. So what we do in this advanced round class, well, first, we check whether the actor of who is performing the action is authorized to advance the contestant. Then we find the contestant. We're using a repository here, not active record. More on that later. We check whether the contestant is approved or not. If they're not approved, we throw a contestant not approved for advancement exception. And then we advance them to the next round. We assign the user who acted. We save the signed contract, and we persist the contestant. Okay, so a couple of words. It basically does the same thing, but as the controller class, but note, please. First, we have a couple of dependencies here. We have actor provider. This actor provider will give us the actor. The actor is the user who is actually doing the action. And why have we abstracted this away? Well, we said that we don't know what kind of environment we're running on, so we don't know how we're going to understand who the actor is, right? It may be from figuring out what cookies they sent. It may be from a token that they send over something as part of a JSON payload. Maybe it's the user who is currently logged into the shell on a terminal session, or maybe we understand which the user is by talking to a third-party service, some sort of an OAuth or something. We don't know this, but we need to get the actor somehow. So we abstract this away. And this fetching, understanding who the actor is infrastructure, because it depends on where and how we are running. So we abstract this away. We do this actor provider thing, which has an actor method. Well, usually people would call it get actor, but I'm really annoyed with the get and set prefixes everywhere. It just kind of blows me, but you get the point. And then the authorization object here, we'll look at it a bit later. Well, we check whether the actor is authorized to advance. Then here with the repository, we find by ID, a bit about the repository a bit later. We have abstracted away whether we have a record for approvals in a method that is called is not approved, because maybe there is another way to figure out whether this actor is approved, not only by checking whether there are records of approval. And then this exception here, it's a domain exception. So it tells us exactly what the error is. And notice that we don't have a message here. I mean, this is pretty clear. We can pass in some more data, of course, if we need it. Just for simplicity of the example, I haven't added any. But we don't care what is going to be presented to the user. This should be done later. This should be done in the presentation layer. Something will catch this exception, figure out, okay, for this exception, I have to send this message in this response code. For this message, it's going to be in this language because the user is from Guatemala, for example, and they needs to be Spanish. So our domain doesn't care about this. It just says, okay, this is wrong. Something else should figure out what the presentation of this error should be. And then it's pretty much the same after that. And seriously? We're working? Are we in the game? All right, we are. And we've abstracted away the logic that persists the contestant. This doesn't really need to be exactly like that, but this is the path I've chosen. And why we're using the repository pattern? Because repositories are very easy to mock. When you have the repository pattern, shall I say a couple of words? A repository is an object that, well, it's a way to abstract your queries to a database or to whatever data source, a database, data source, files, whatever, it doesn't matter. They abstract the way that you retrieve information from it, from this. So the repository's job is to have this interface find by ID or find everybody named Josh or find the people who didn't pass. You have methods like this. And usually the implementation of the method would be creating a query to a SQL database. That would be like the most common thing that we use, but it may be a query to an Elasticsearch index, or it may actually dig into some files, or it may use a cache before it actually makes a query to the database. You don't care about any of this. It's encapsulated by the repository. The repository is in charge of knowing how things happen. The repository knows your infrastructure at that level. So this is why having the repository is really nice. Second, it's like really easy to test, because having an in-memory repository of objects is basically just an array where you map by class name and ID, and you're good. And your tests run like super fast, because it's all in memory. And the persister here, the reason I use the transaction for this is, well, see how the signed contract, it's some sort of an object that we assign to the contestant, and then the persister, the transaction here, it's the one that knows that maybe we should persist the data for the contestant in a SQL database, or maybe in a file, or maybe in, as I said, for example, Elasticsearch index. And it should also know that when there is a file here, the file should go to a file storage, or a cloud storage, or a FTP server, or whatever. And the repository should also know that when it's reconstructing this contestant object, it should know where to get the file from. So this is why we have all these objects, so we can abstract all this stuff away. And we're left thinking only about our domain. So let's look at the dependencies here. First, I forgot to tell about this. That's very important. The parameters object. It's a value object. What is cool about value objects? They are, well, if you've, if you've done them correctly, they're always valid. So because they're always valid and because they self-validate, I've moved the validation into this value object. So when you create the value object from an array, for example, it validates the data passed in, then it creates an instance of itself, it assigns the validated data and returns the instance. And now you know that this is valid data, and you can pass it around to different stuff. It's cool. And it abstracts away, whether it's HTTP, whether it's console input. You don't care. You pass in an array, it validates. Now, notice that I'm talking about being married to the framework, but still I'm using this Laravel validator here. Usually with value objects, I wouldn't do that because you would validate like 2 or 3 things, and you can just go with if and then. It's not a big deal. But this being an object for which is a command for a use case, we may end up with more stuff to validate. So it's handy to have a validator. And it doesn't really matter that much that we're married here to our framework, because, see, this will throw an exception. But this exception would be caught by our infrastructure code, by what is in our framework. So it's kind of fine. It's a nice trade-off. And it's really not that hard to get rid of only the validation. If for whatever reason the validator becomes a problem, it becomes unmaintained or buggy or whatever, well, it's not that big of a deal that you just do the validation in your value objects yourself, like replace them somehow. I mean, yeah, it's still not very pleasant, but a trade-off. I think that's an okay trade-off. So, yeah. And again, testing. This allows you to test your use case or application service with different parameters without actually knowing where are you going to be running this. You're guaranteed that wherever you're running this, once you pass in data from the environment into this validation object, if it doesn't throw, it's going to be valid data, no matter where it comes from. You don't need to validate the request. You don't need to validate the command arguments. You need to validate the parameters object. The actor provider, as I said, is just an interface. This can have many different implementations depending on where we're running. It can be an implementation that will somehow figure out who the actor is based on cookies, or based on OAuth, or based on the person the user who's logged into the current terminal session. Doesn't matter. And now the contestant authorizations. This is infrastructure. This is domain. Why is this not an interface? Well, because it's specific rules of our domain. Why is, we said why authorization, authentication, why authentication is infrastructure. Why is authorization domain? I mentioned this before, but again, it is part of your domain knowledge. Who is allowed to do what? Who is supposed to do what? Who is not supposed to do what? This is part of your domain. The contestants are not allowed to advance themselves up the levels. The assistant directors, they're not allowed to, for example, I don't know, decide what the makeup for a contestant should be. The producers are not allowed to describe what time codes are there on a tape. This is all domain logic. So the authorization is part of your domain. And it doesn't change throughout the environments either. So it's simple class, just if the user row is not that, just throw unauthorized to advanced user. And this is also a domain exception. We can pass in the user who's trying to do it here, but didn't think of that. Sloppy. And the contestant repository, as I mentioned, it's interface because it's infrastructure, and the different implementations of this interface can talk to different databases, to different storages. And the transaction, same as the repository, is also an interface because it also has to deal with the infrastructure, and it may have a lot of different implementations. So once we refactored this, let's look at our controller. This is what it looks like now. Yeah, I also like one-action controllers because of this, a lot of dependencies, doing everything controllers. So one-action controllers, I think they're pretty fine. I've heard the argument that we get an explosion of classes, and well, otherwise you get an explosion of methods. And I don't know why people are afraid of a lot of classes. It's fine, as long as you can navigate through them, and it's called advanced two-round controller. So I also would drop the controller because it's usually in a namespace, but that's not important. So what we do is we inject the use case, the application service, into our controller as a dependency. It gets built by our dependency injector because we're using framework the right way, and it's cool. We got dependency injection, that's really nice. And our invoke, because I told you why I like the invoke. Well, it basically just takes the request, stuffs everything into this, into creating the parameters object. It may fail, it may not fail. We may catch in the controller, we may leave it for something more general to catch this. It executes the action, and then we return the redirect. And this is all actually stuff to do with our infrastructure. We're left with infrastructure code only. So basically that's it. What do we got? We got more expressive structure. We got no infrastructure worries in our model. Distinguishable bounded contexts, really do controller actions. The reasons I like all this stuff, the trivial reason is it's really easy to test. That's a byproduct. Being easy to test is a byproduct. The really valuable part is that this kind of approach, it gives you the freedom to think about your domain and to design your domain without thinking about infrastructure. So you're just focused on what needs to get done. And you can actually write the whole thing, because you mock your repositories, you mock your storages. You don't care whether it's HTTP requests or something. You test your data validation, you test what it does. You see whether it does it well. And then you start worrying about how should I structure my SQL query? What are the parameters called? Is it a get or a post? Is it a put? Is it the JSON that we are serving? Is it XML? Is it SOAP server? You don't care about any of this. It really frees your mind to actually focus on the domain. And when you focus on the infrastructure, to know what this infrastructure should actually do. Because you know, the infrastructure should serve your domain. It's not the other way around. So it lets you start with the domain. Pretty much that's it. It's a couple of slides here, which are, because I obviously picked up the wrong version. Yeah. So a couple of inspirations that I had. So obviously domain-driven design, tackling the complexity in the heart of software by Eric Evans. Clean architecture talk, which is like, it's a very great talk. And there's, after the talk was given, there is a book now about this talk from Uncle Bob. And action domain responder, yeah, we didn't talk about this because after, yeah, as I said, I picked up the old version of the slides. It's an interesting concept that I had tried and applied, and it's okay, but decided that it's not that important for this talk. So thank you. This is me. Those are my handles, my LinkedIn, my mail, and yeah, the usual stuff. I'll be upstairs having beer, unless you have any questions.
Yep. Milko, that's a nice photo.
Yeah, I squinched for this one. Like, it was like, squinch a bit more.
I know the drill. So, do we have any questions for Milko? Just raise your hand, and Mike will come your way. That silence. Oh, we have a question over there. Please.
Oh, Jesus.
Oh, no. Maybe it was faster to use the, but, okay. Oh. Let's see.
Yeah, Milko. So you've given this talk a couple of times before over the last.
Sorry.
You've given this talk before.
Yep.
And that was maybe a year ago or two. Mm-hmm. And it's a very interesting talk. But I was wondering, when are you planning on releasing your framework to allow us to do this in a more structured way?
I dropped the idea of framework for domain-driven design because it doesn't make a lot of sense. Basically, what I realized is that I was wanting to do a framework. What I was going to do was a framework for that implements action domain responder. And then I had to do a couple of simple DO controllers, and they're so simple with DO that I don't really know if it's worth it now. So that's the answer to your question, I hope.
Okay, any more questions? Oh, front row, first row.
Yeah, first of all, great talk. Really enjoyed it.
Yeah, thanks.
I'm really into DDD, and I love the things you discussed. But one of the biggest pitfalls I've noticed with this kind of setups is that the entire team has to be on board. Because once some people take some shortcuts in their value objects or in their bounded context, it all kind of falls apart and it gets a bit messy.
True.
Do you have any tips surrounding those things?
No, unfortunately, I couldn't do this exactly because of the reasons you're describing in the last project that I did, like the last big thing. And quite frankly, this project really needed this approach. But we started with not doing this because of the exact same reasons that you're describing. And maybe, no, I don't have any tips. Like, seriously, if anybody has some, I would be like super happy to learn them. Like, no. Maybe if you're in the position to enforce this, other than that, not really. Sorry.
Okay, cool.
But you're correct. Like the downside to all of this is that you actually have to know what you're doing, and you have to be aware of the patterns in order to utilize them well, because otherwise, yeah, you take the shortcuts, you start doing stupid crap, and this all goes to the trash bin. So this is not a recipe for not a disaster. It's how to avoid it. But yeah, downside, it takes more practice, effort, knowledge, call it whatever. I don't really know, desire, discipline, whatever, to be actually able to do that. So I've been wondering whether this is a talk for. Well, the first time I gave this talk, on the call for papers, there was levels like, is this like an advanced talk or intermediate talk or a beginner talk? And I said it's an advanced talk, quite frankly. I was not sure though. I'm not sure because it is kind of easy. It's not that big of a deal, and still, like the hard part comes. The hard part is not actually following the patterns and the rules. The hard part is to actually understand what you need to build. And this is until you actually realize what you need to build. This is where the mess actually comes. And yeah, you tend to cheat because you implementing patterns and stuff while you do not know what you actually need to build. Well, Antonio talked about this, like just patterns. So people in the team have to be experienced, or at least there needs to be a team leader that needs to be experienced in this kind of stuff in order to explain, lead, and so on and so forth into this. No other tips. Don't know.
Thank you.
Yeah.
Actually, Milko had a question. Okay, any more questions for Milko? Going once. Okay, so that's it. Let's hear it for Milko Kostrukov.
Thank you. Are we upstairs? Thanks.
Okay.